Hello everyone, I'm Bhagwat Guli from Rajanbabu Institute of Technology, presenting development in microcontrollers in front of you. I'll start with introduction. A microcontroller is a solitary chip microcomputer fabricated from VLSI fabrication. A microcontroller is also known as embedded controller. Today, the various types of microcontrollers are available in market with different word lengths such as 4-bit, 8-bit, 64-bit, 128-bit microcontrollers. Microcontroller is a comprised micro is a compromising components like memory, peripherals, and most importantly, a processor. Microcontrollers are basically employed in devices that need a degree of control to be applied for the use by the user of device, computer manufacturer to control the function of embedded systems in office, machines, robots, home appliances, motor vehicles, and the number of other gadgets. I would like to tell you the basic difference between microprocessor and microcontroller. I'll start with microprocessor. Microprocessor assimilates the function of central processing unit onto a single integrated circuit, that is IC. Whereas microcontroller can be considered as a small computer which has a processor and some other components in order to make it a computer. Microprocessors are mainly used in designing general purpose systems from small to large complex systems like supercomputers. Microcontrollers are used in automatically controlled devices. Microprocessors are basic components of personal computers. Microcontrollers are generally used in embedded systems. Computational capacity of microprocessor is high and less computational capacity of microcontroller. Here is the block diagram of microprocessor and microcontroller, which shows the difference between microprocessor and microcontroller. Microprocessor contains address bus, data bus, control bus, ALU, that is arithmetic logic unit, CPU, central processing unit, register, that is on-chip memory, and control unit. Whereas microcontroller contains address bus, data bus, control bus, CPU, and RAM and ROM, that is random access memory and read-only memory, and main components, that is input-output ports. Microcontroller also contains counters and timers, which distinguish the microcontroller from microprocessor. Also, the main difference is the clock frequency is very high, usually in order of gigahertz in the microprocessor, where the clock frequency is less in case of microcontroller, that is the megahertz. I'd like to tell you the basic components of microcontroller. Microcontroller contains CPU, memory, input-output ports, etc. I'll start with CPU. CPU, everyone knows the CPU is the brain of computer. Similarly, microcontroller brain is named as CPU. CPU is the device which is employed to place data, decode, and execute it at the end to end the task. Then memory. Memory, the purpose of memory to store all programs and data. The microcontrollers are built with a certain amount of ROM and RAM or flash memory for the storage of program source codes. And the main component, that is input-output ports, which distinguish microcontroller from microprocessor. I/O ports are basically employed to interface or drive different appliances such as printers, LCD, and LEDs. Input-output ports, which also can take the input of different sensors and give output to the system. Then serial ports. These ports give serial interfaces amid microcontroller and various other peripherals such as parallel port. Then timers and counters. Timers, the purpose of timers, the counters, is used for the pulse generations, clock functions, frequency measuring, and modulations. Then ADC, that is analog to digital converter. As microcontroller itself is a computer, so we require ADC because computer understand the language of 0 and 1 only. So we require to convert the electrical signals into digital signals. So we require analog to digital converter in the microcontroller. Also, to give output from the microcontroller to the system, we require digital to analog converter, which will convert the 0 and 1 into the electrical signals in order to get the accurate output. Interface control. This controller is employed for giving delayed control for working program. The interface can be internal or external. Then types of microcontroller. Microcontrollers are divided into categories according to their memory, architecture, bits and instruction sets. So let's discuss the types of microcontrollers. Bits. Everyone know as per the bits we have 8 bits, 16 bits, 34 bits. Right now we have 64 and 128 bits also. 128 bits microcontrollers also. The 8 bits was the basic microcontroller, and the example of 8-bit microcontroller is Intel 8031 or 8051. Then comes 16-bit microcontroller, which executes the program with greater accuracy and performance in contrast to 8-bit. And its example is 8096. Then 32-bit microcontroller is employed mainly in automatically controlled appliances such as office machines, implantable medical appliances, etc. As per the memory, we have two microcontrollers, that is external memory microcontroller and embedded memory microcontroller. The basic difference between external memory and embedded memory microcontroller is that in the external memory microcontroller, we require the external memory for the microcontroller. And the typical example of external memory microcontroller is Intel 8031 microcontroller, which do not have program memory on the chip. And the embedded memory microcontroller, which itself contains the RAM, ROM, and on-chip memory. And the examples are 8051 microcontrollers, which stores all the programs in data memory. And as per the instruction set, we have two types, that is CISC and RISC. CISC means complex instruction set computer. It allows user to apply one instruction as an alternative to many simple instructions. RISC means reduced instruction set computers. RISC reduces the operations time by shortening the clock cycle per instruction. Then memory architecture. We have a Harvard memory architecture microcontroller, then Princeton memory architecture microcontroller. The basic microcontroller is 8051 microcontroller, which was derived already, and which was initially invented by 8052. And this microcontroller has 3 times and 256 bytes of RAM. And in this family, we have two members, that is 8031 and 8051. 8051 microcontroller brings into play two different sorts of memory, such as NVRAM, UV EPROM, and flash memory. It is used to store the program source code's data. And here is the 8051 microcontroller architecture. We can go through it. It is simple to understand. Then PIC microcontroller. PIC means peripheral interface controller, provided by microchip technology to categorize its solitary chip microcontrollers. These appliances have been extremely successful in 8-bit microcontrollers. The foremost cause behind it is that microchip technology has been constantly upgrading the appliance's architecture and included much required peripherals to the microcontroller to go well with clientele necessities. PIC microcontrollers are very popular and hobbyistics and industrialized. This is the only cause of widely availability, low cost, large user base, and serial program capability. Here we have PIC microcontroller architecture. It is simple. PIC microcontroller architecture consists of 3 things: baseline architecture, mid-range architecture, and high performance architecture. Then AVR microcontroller architecture. AVR microcontroller architecture was developed by Alf Egil and Bogan and Wingard Wallen. The name AVR is derived from the names of architecture developers of the microcontroller. The Atmega 90 S8511 was the foremost microcontroller which has AVR architecture base. On the other hand, the foremost microcontroller to strike the commercial marketplace was AT90 S1200, which was launched in the year 1997. The SRAM, flash, and EEPROM are incorporated on a single chip, thereby eliminating the requirement of any other external memory in maximum devices. Microcontroller applications. It is really necessary to know the microcontroller applications. First is application of microcontroller in day-to-day life devices. light sensing and controlling device, temperature sensing, fire detection. In industrial control, we have industrial instrumentation devices, process control devices. In application of microcontroller, in metering and measurement devices, we have in the voltmeter, measuring revolving objects, current meter, handheld metering system. Thank you.